Hello everyone, and in this video we're going to be solving quadratic inequalities, and these are quite tricky ones. So these are the kind of ones that would appear towards the end of a GCSE paper, maybe one or two questions, two or three questions in from the end, and would be also required to know how to do this for A level. So let's have a look at the first one. So we've got to solve the inequality 2x squared minus 9x plus 4 is less than or equal to 0. Okay, so the first thing that we're going to do is we're going to, if you're doing GCSE and you're not doing IGCSE, you have a non-calculator paper. So I'm just going to show you how you would factorize this if this came up on a non-calculator paper. So if this came up on a non-calculator paper, and these kind of questions do come up on regular GCSE on a non-calculator, you would start off by saying, I'm going to times the 2 by the 4. So 2 times by 4 is plus 8. Then you've got the minus 9 in the middle, so you write that down. So then you say to yourself, I'm looking for two numbers that times together to give me positive 8, but add together to give me minus 9. And we can see that that factor pair is going to be minus 8 and minus 1, because minus 8 times minus 1 is plus 8, and minus 8 add minus 1 is minus 9. So that's our correct factor pair. So we're going to split this middle term now into the minus 8 and minus 1. It doesn't matter which side I put them on. So actually, why don't I write the minus x there? That's minus 1x and minus 8x there. So again, I could equally have written them the other way around. So I now write down the 2x squared from above, and I write down the plus 4 from above. And I'm now going to factorize these two terms and these two terms. So I'm going to take out a factor of x here, which is going to leave me with 2x minus 1. Here, I'm going to take out a factor of minus 4. So I take out minus 4, and that leaves me with 2x minus 1 as well. And then what happens is the terms that are in front of these brackets, we know it's correct if these two brackets match, by the way. So because they both say 2x minus 1, we know that we're on the right track. And then what's written in front is the other bracket. So that is, we're essentially going to factorize out the 2x minus 1 from that whole expression. And we'd be left with x minus 4 times by 2x minus 1 is less than or equal to 0. So that's how you would approach factorizing a quadratic with a nonlinear coefficient of x squared, in other words, a number in front, if you had this on a non-calculator paper. If this came up on a calculator paper, then what you would do is you would use your calculator to reverse engineer the brackets, okay? And for those of you that are doing GCSE, I strongly recommend that you get a calculator that you can use to factorize. And what you would do is you would get your calculator and you would find it where it is here. And it's going to be a polynomial of degree 2. And you just enter the quadratic in. So in this case, 2x squared minus 9 plus 4. Okay. And you put that in, and it tells you that one of your solutions is 4 and the other solution is a half. So this, you would write this down as you would say x is equal to 4 and x is equal to a half, just from your calculator. So I'll write down here or, because this is the non-calculator way, and this is the calculator way. Okay. So in our calculator way, you enter it in, your calculator gives you those solutions. So you now reverse engineer your brackets by rearranging these to make them equal 0. So in this case, x minus 4 would equal 0. And I would times by 2 and take away 1. So 2x minus 1 equals 0 would be my other bracket. So my kind of like, almost like a cheat reverse engineering method of factorizing that quadratic using my calculator, I can see that the brackets would be x minus 4 and 2x minus 1. Okay. Okay, so that's all of that to say that's the first step. We've got the quadratic factorized. Okay, so this is, you know, quite a tricky, probably say a solid grade 8 question. So we factorized it now. Okay, so let's just write the whole thing down, factorized. So the factorized is x minus 4 times by 2x minus 1 is less than or equal to 0. Now, once we've factorized it, the thing we do is we're going to draw a sketch. We know that our solutions are x is equal to 4 or x is equal to a half. X is equal to 4 or x is equal to a half. So if I put a half there, then you draw a quadratic with x equals 4 and x equals a half on, like that. Now we're looking for this expression to be less than or equal to 0. And the region in question for less than or equal to 0 is this region underneath the curve here. So that's what we're looking for, this region underneath the curve. And this is a continuous region. So our answer is going to be x is less than or equal to 4, but greater than or equal to a half. So that would be our answer. That's how we would write it. Now, if the question had said this instead, if it had been solving the whole thing but greater than or equal to 0, instead of it being less than or equal to 0, what we would have done then is we would do the same thing. We would sketch our quadratic. We would label it as 4 and a half, our solutions. But this time, because we're looking for greater than or equal to 0, we'd look at the graph and say, okay, where is the graph above the x-axis? Or where are the y values greater than 0? And you can see it's these two regions I've indicated here. And then going that way and going that way. Now, these two regions are x is greater than or equal to 4, that's that region, or x is less than or equal to a half, which is that region. So if this original question, instead of saying 2x squared minus 9x add 4 is less than or equal to 0, if the question had said solve 2x squared minus 9x plus 4 is greater than or equal to 0, we would have factorized it in the same way. We would have drawn our graph, but this time we would have been looking for the regions that are above the x-axis, and we would have found that we would end up with two separate regions. So that's an example of how you would solve a quadratic, quite a tricky quadratic inequality. I hope you found that useful, and I will see you in the next video.